Okay, are we on?
Yeah.
Okay, we are live. So, take out please your worksheets.
Sorry, the cow ate it.
Okay, cow, I'll shoot the cow and eat your homework. We're looking at large inequality functions, 2b-12, and let me see if I can find one. Okay, so let me see what we have. And we will just do these straight on the board. It would take less time than Alrighty. And by the way, hi everybody from home. We're here.
We're disappointed in you.
You guys. Okay. So let me just start on the actual worksheet. This is 2b-12. Enlarge it so that I can actually read it. Okay. First thing. Problem number one. Y equals, rather than actually try and read off the answers, I'm going to just step through them at the same time, I think. Y equals, x minus 3 parentheses cubed, is that right? Times x squared minus 1 squared, times x to the 6th. And that's all over x to the 5th. X plus 1 to the 3rd, and then x minus 7 to the 5th. All right. It's already factored, so you don't have to do that. Can anybody list roots? Well, they're roots, vertical asymptotes, and holes. I would actually ask you to get the holes first. Those are usually nicest to get out of the way. You see it? Yeah.
Will we have a hole with the x, just the x being fixed next to the bit?
Right. We've got apparently so far, we've got a hole at x equals 0. How many of the x's cancel?
5.
5. How many are left?
1.
1 on top. So I'd say there's a hole at x equals 0. And it doesn't really, holes are creatures that don't really care if there's multiplicity or not. It's kind of like you put a bottomless pit on top of a bottomless pit on top of a bottomless pit. It's a bottomless pit. Yeah, you're really not changing anything. But just for reference. However, so I'll list that as x equals 0. And even though it's kind of a math joke, I'll say a quintuple hole, which is still a hole. Well, that hole I emptied 5 times the amount of stuff in there. There was nothing in there to begin with. Well, yeah, it was easy. Okay. So, anything else you see? Yeah.
That x squared minus 1 squared.
Yeah, what's that?
That's x plus 1 and x minus 1.
Correct. Only there's double. If you have x squared minus 1 parentheses squared, that's really x plus 1, x minus 1, x plus 1, x minus 1. Does that make sense? So if you factored it all the way out, you'd have doubles of everything. So what does that give you?
It gives you another hole.
Oh, interesting. So actually, I could probably just, yeah, why not? Life short. X minus 3 cubed. I'm going to do this. X plus 1 squared, x minus 1 squared. Does that make sense? They keep from here. And then there's only an x left. Then down the bottom, this is canceled. Then there's x plus 1 cubed. You know what? I'm just going to do this. I just want the fun of canceling everything. Bam, bam, boom. Okay. So, and then we have x minus 7 to the 5th. And yeah, you notice there's another hole whole at x equals where?
X equals
Negative one, good. And that's like a double. Again, we really don't care what multiple scale whole is, but I'm just mentioning that. So we have a running total. Any other holes in mixes? I do not. So what else is in there? To this issue. Are there any roots that survived that battle? Sorry? X equals 3? Okay. What kind of a root is that? Triple. Anything else? X equals 1. What kind is that? Double. Anything else? X equals 0. What is that? Single. Okay. Those are the roots that survive. Pete, take over. Any vertical asymptotes? X equals -1. Single, double, triple? Single. Yeah, that survived. And then anything else? 7. Any other word for 5? Quintuple, very good. So those are our breakpoints. Does anybody see any wars? Where? X equals -1. There is a war between a whole and a vertical asymptote. Who wins? Vertical asymptote, definitely. This whole got wiped out. Do you see any other wars? Check well.
There's the zeros
Yes.
and the whole ones.
Yeah, so a war between a what and a what?
Root and the whole.
Between a root and a whole, who wins?
The whole.
The whole wins. There is no longer a, now, does everyone remember anything special what happens? A war with a root and a whole? There's something, there is a whole out there, but there's something special about it. Where is it?
On the x-axis.
Yes. This means that there is a whole at x equals 0 on the x-axis. So in short, that whole is at 0, 0. So I know it's x equals 0, but on the x-axis it also means y equals 0. So there's a hole in dead center of the graph. All right, now let's graph this thing using plus-minus notation first. We want to do a graph ultimately, the full-fledged graph, but I want to do plus-minus notation to find out where there's above or below. Can somebody list off the surviving breakpoints from left to right? 5. There's one a little before that. -1. So what's that -1? Correct, the vertical asymptote. And then there should be something at 0. So it's there. I'm sorry? That's a whole. There you go. What's next? Okay. What kind of a root? Double. Good. Take over. No. So we've got -1, 0, and 1.
Yeah, there's a 3.
There's a 3. Okay.
The root.
Triple root of 3. Okay.
Then you have vertical asymptote at 7.
Yes, correct. What kind?
And that's a quintuple root.
Quintuple root. Is there anything else?
No.
I think we're set. So we've got 5 breakpoints that will break it into 6 regions. How you want to run this? Please take over.
Well, 220 and 2.
Yeah, I'd love to plug in 0, but it didn't work. So plug in x equals 2, and then tell me what I get for y. Again, here was the original, that's why I had to rewrite everything. Just write out all the surviving stuff. You don't have to write down the stuff before the whole's canceled. So y equals, the top, there's this thing cubed, and then what's next?
X minus one,
Yeah, and that's squared, and there's a
there's an X,
x at the end. What's still alive on the bottom?
and then X plus one,
X plus 1 thingy,
and then X minus seven to the fifth.
good. Plug in a 2 and tell me in each part of these, positive or negative.
That would be negative.
Yeah, 2 minus 3 is negative 1, and make sure you cube it, that's still negative. All right, well, actually, we'll cube that in a second. How about here?
Positive.
Positive. How about here?
Positive.
Positive. Here?
Positive.
Positive and
Negative.
negative. Look carefully on the powers. How many total negatives are there?
8.
8. There are 8 negatives. What does that make?
It'd be positive.
Positive, exactly. So this region is positive. Now we have to look really carefully at the multiplicity. There are a lot of goofy multiplicities in here. Realization. Go to the right from here. We're hopping over a triple root. Does it switch? Yes, it does. And what if you hop over a quintuple asymptote? Yes, it does switch. Anything that has an odd multiplicity of roots or vertical asymptotes, that should switch the sign. Polly, go to the left. What about over a double root?
It doesn't switch.
It does not switch, so it's still positive. What about over a whole?
It does.
Why? Normally it doesn't.
Because it's on this.
Right. This is one of those rare sort of alien holes. Normally a hole is in the middle of nowhere. If you're above the x-axis, it'll just interrupt and stay above the x-axis. This is one of those weird holes that's actually on the x-axis. That's the result of the war. So that will in fact switch. And how about a single asymptote?
Switches.
Switches. Okay. Now, if we were doing an inequality, we could just grab one of the regions that work and go. I want to try an actual graph of this thing. Just double check and make sure this is on screen. Hi y'all up in Homeland. Oh good. Homeland. Sound like Department of Homeland Security. Whatever. I see a few objects. I see some roots at 3. And that's a triple root. I see a root at 1. And that's a double root. I see a vertical asymptote at x equals negative 1. Plain old. I see a vertical asymptote at x equals 7. 1, 3, 7. And this is a quintuple. And there's a hole exactly at 0, 0. So, can somebody direct me what to do next? I want to sketch a reasonable sketch of this graph. There are a few, oh, by the way, look at the instructions. Sketch an accurate graph, list all intercepts, all asymptotes, and exact locations of end holes. We've got the exact location of the hole, and we've got the vertical asymptotes. What else should we look for? Good.
Y-intercept.
Y-intercept. That's usually fairly nice to find. Y-intercept. How do you get Y-intercept? Plug in x equals 0. And by the way, plug it into the canceled version. So it looks like this. Y equals, plug in a 0 here, what would you get?
Negative 3 cubed.
Negative 3 cubed, I'll do that in a minute. That's gone.
Negative 1 squared.
Negative 1 squared.
0.
Interesting. Okay. you could probably piece together what's gonna happen, but this is gonna be one, and this is gonna be -7 to the 5th power. Before you do a lot of work on this, which is really horrendous, let me tell me what the answer is. It's gotta be 0. It's out to 0. Does that surprise anybody? Why do we have a y-intercept, quote unquote, at 0? And interestingly enough, we're going to have to amend this. Look at the graph. Does anybody see what's causing all this mess? Here's the y-axis.
The whole.
The whole. Yeah. Not only is that an x-intercept is replaced by a hole, the y-intercept is replaced by a hole. So technically, even though it said 0, there is no y-intercept. It's a hole on the x-axis, which is kind of a fake. They're saying, wow, there's something on the x-axis, it's got to be a root. Oh, darn it, it's a hole. So, y-intercept is a bust. There's one type of asymptote, 2 other types of asymptotes we haven't checked yet. Here they say, Sean. What are the 2 types of asymptotes are there? Horizontal? And the other one, which is called what, anybody? We got horizontal, and what other type of asymptote?
Vertical.
We got vertical,
Uh,
and horizontal, and then
oblique,
oblique, which is diagonal. So how do you tell if there's a horizontal or an oblique asymptote in this thing? Just for giggles, let me rewrite the entire thing. Where can I squeeze it in? I'll just do it down here. Y equals, which is x minus 3 to the 3rd, x squared minus 1 squared, then x to the 6th, all over, I'm doing this for a reason, all over x to the 5th, then x plus 1 cubed, then x minus 7 to the 5th. Okay. What is the degree of the top? Yeah. Say again? It would be, except these are joining forces with multiply. What's the degree of this piece by itself? If you multiply this out? What? 3. Right. It'll be x cubed plus a bunch of junk. How about this one? Look carefully for the decision. What happens with power on power? What? Not add, but. What do you mean? Yeah, multiply. If you had like x to the 3rd power raised to the 5th power, that's x to the 15th. Same thing here. X squared is really what? X to the 4th. So this is power 3, power 4, power 6. Big combined forces. What do you have? What's the degree of this top? No.
13.
Degree is 13 on top. Can somebody tell me the degree of the bottom? Jack Bob.
It's 5.
These are joining
Oh,
forces.
no. 13.
It's 13. What does that say? The degree on the top and bottom are identical. What kind of asymptote are we looking at here? Check your notes if you need to. Does everybody have their notes? Yeah.
Looks like a horizontal asymptote.
It's a horizontal asymptote, correct. If the degrees are equal, or if the bottom is bigger, horizontal asymptote. When does an oblique asymptote show up? You do need to have this memorized. When does an oblique asymptote show up? Horizontal asymptotes show up when the degree of the top and bottom are equal, or if the bottom is bigger. When does an oblique show up?
As x approaches positive or negative infinity,
Okay.
and y is some kind of diagonal line.
True, that pretty much describes what it looks like. What degrees cause an oblique asymptote to appear?
I don't think we have that now.
We do.
No,
I wrote it at least twice.
we did the vertical asymptotes and the horizontal asymptotes, but we never did the oblique one.
Maybe I did calculus. Huh.
We wrote down
I'll show you.
oblique type.
Yeah.
I have it, yeah, 3 types of asymptotes, but then, yeah, just like oblique and then as x.
Yeah.
As I said, that's all I told you?
We did that, but we didn't do.
Okay, I'm the
degree
degree, so.
But, yeah,
Let me-
that was,
I will show you when it appears. Just to give you that, remember when you run x to infinity, what are the only terms you have to pay attention to? Yeah, the dominant terms, the terms that are biggest. Now, the dominant terms can be hiding, because when they're multiplying these together, you don't know what the dominant term is until you multiply it out. What this thing really is x to the 13th plus a whole bunch of other garbage. And on the bottom, it's going to be x to the 13th plus a whole bunch of garbage. Can somebody tell me what the horizontal asymptote is? I'll get to the oblique asymptote in a second. But as x goes to infinity, y is approximately equal to what two terms? They're sort of staring at me. What's the dominant term on
One x
top?
to the 13th and
X,
one
1x to the 13th plus over
1x to the 13th.
1x to the 13th. Does that reduce?
One.
You're looking at your horizontal asymptote. Because the horizontal asymptote of y equals 1. So on the graph, do this. Go up to 1. Horizontal line. Now remember, vertical asymptotes are absolute. You do not touch them, ever. No graph will touch a vertical asymptote, ever. Unless it's not a point. But, I'm just getting my water, people who are watching at home. I didn't just leave the room. Horizontal, sometimes you can get a graph across. That's what was tripping me up. I did like a day or two in calculus to review this stuff. And so I think I gave them more than I gave you. So, just for now, use plus minus notation. To the left of -1, 0, 2, 3, 7. Where's the graph? B. Positive, what does that mean? It's above the x-axis. Now, I'm not sure whether it's above in this little region here or above that. They didn't say. I'm going to start way over here. Actually, I probably should. Because that's the same problem. Start here, in this zone here between 3 and 7. Where's the graph? It's below. Am I right? This is the negative region. Here's a vertical asymptote. If you're chasing it, do you expect that to go up or down? What's that?
Down.
Why down?
Well, because it's negative, it wants to stay negative.
True, and that's another reason.
And cross and we have a root.
If it went up, it would cause another root, which we don't want. So here, we know it's going to swoop down. Oh, people who remember your multiplicities. Julia's turn. What happens at a triple root? Does it go through, bounce, or swerve? Swerves. So it's going to do, I should draw this a little better. It's going to flatten out and go up even more. What's it going to do next? Oh, look at the objects that are about to hit.
is there kind of root,
It's going to go straight through. How come?
uh,
What is this thing?
just a single root?
It's a single root. So it may go up a little bit, I am not sure how far, but it's gonna go right back down again and go straight through. What's gonna happen after that? Jeff? I'm going down here, then what?
it'll go, hold on. Will
Yeah,
it
there's
go
something funny
back
about this.
up? I mean, it's supposed to go towards the hole, so it's gotta go back up, but it doesn't go through.
Oh, wait a minute, oh, hold on, I'm an idiot, this is one. I did it, this was a, it was a double root, I forgot the little X, my bad. Double root. Sorry, so what happens on a double root?
It, bounces.
Bounces, right. And if you look over that's why I was getting all scared with plus minus notation. Because it goes from positive to positive. It tried to go below, but it got bounced back up. This tells us it bounced, and a double root tells us it bounced. What's gonna happen next? Where's it gonna have to hit next? Through the hole, exactly. When you get to here, between 0 and 1, is it positive or negative? Or, well, as you pass 0, is it going to switch the sign? Yes, it goes into negative, which makes sense. Where's it going to go as it approaches this asymptote? Up or down? Is it going to swoop down or swoop up? Down. How do you know? It's negative for one thing, and what would happen if it did go up? It would cause another root, which we don't want. That makes sense? That's a sort of detective work for me. This is a single asymptote, I think, a negative 1. Yeah. So single asymptote, did they swerve opposite ways or same way? No.
Opposite,
Opposite. So if it goes down, where does it reappear?
up top.
From above, up top. So it's not in this zone at all. And guess what happens as it goes further to the left?
It approaches, 1.
Yeah, it's going to flatten out and follow the force on asymptote. So do that same trick over here, Pete. Quintuple asymptote, opposite direction or same direction? Single root had going opposite.
Would it be the same direction?
Well, single root is opposite, double is same.
Oh, no, it'd be opposite.
Yes, why do you say that?
Because it's an odd number.
Exactly. And by the way, if it's a quintuple root, what happens to the graph? If you keep piling asymptotes and asymptotes on, what happens to the graph?
We get flatter.
It gets flatter. So it's going to look like this. It's going to take a much sharper turn than normal. And up here, ditto. It's going to have a much flatter. It's not going to have a very smooth graph. This is pretty much what the graph looks like. There, congratulations, is number 1. Yeah. That's kind of how I looked the first time I did a problem like this. We do all the heavy lifting that all the other math classes except for calculus are scared to touch. So actually even calculus got nervous with this stuff because they didn't remember it. So you're actually, believe it or not, you're actually in pretty good shape on this. If you know how to handle multiple roots and multiple asymptotes, and if you know how to do plus minus notation, and know how that multiplicities flatten things out, you're way ahead of 99% of the people in the world. Most people just do not know how to handle this. So, yeah, me too. I know. I'm not saying it's fun, but I'm just saying you do have the ability to play with something that not many people can handle. So, not that I want to give you a big head or anything, but you're actually in pretty high-powered math right now. So let's take a look at number 2. Number 2 was, believe it or, well, you'll believe this. Solving inequalities is actually a lot easier than trying to sketch. You don't have to worry about flattening out or whatever. Let's try number 2. 2 parentheses x minus 1b. X plus 5 is 7. X squared minus 4 to the third. All over x minus 2 to the fourth. X to the 10th. would simplify this first. There are some things hiding in there that you might find useful. What is x squared minus 4? Oh, factoring people.
2i.
Yeah, I know, yeah, we're gonna wait till that. If you factor this, what would you get? X squared, yeah,
X plus 2x minus.
x plus 2x minus
Both of them.
2. You just have tripled both of them.
Oh, yeah, not 2i, just 2.
Right. And so I'm gonna rewrite this as 2, I'm gonna recopy almost everything. And x plus 5 to the 7th. I'm gonna do this, and I wanna make sure everybody knows what I'm doing. Everybody see where I got this? These are two new things. They came from here. So if you factor this, you'll just have triplets of both of them. But it's easier this way to see the wholes. So x minus 2 to the 4th times x to the 10th times x plus 5 to the 7th greater than or equal to 0. So, tell me how to do this. Start me off. Try it. Good on. Do this yourself. Where would you start in a mess like this? Yeah, let's find the breakpoints. Okay, let's find the holes first. Are there any? X plus 5. So x equals what? X equals negative 5. You don't really need to list a multiplicity for holes. It really doesn't matter. Any other holes? Yeah, right. X equals 2. Yeah, the x minus 2's cancel. Is there anything left? There's an x minus 2 on the bottom, correct. So there's a hole at x equals 2, at least temporarily. Anything else? Any other holes? Probably not. Correct, there are none. Polly, any roots?
We would have x equals -2.
Okay, so x equals -2.
Um,
That's here. Oh, what kind of a root is that?
Triple.
Triple root. Okay, anything else?
X equals 1.
X equals 1, what kind of a, oh wow.
I don't know.
You can just tell me the multiplicity.
8.
Multiplicity of 8, yeah, people usually do that. It's an octuple, if you want another word for it. But it's just easier to say multiplicity of 8. Especially if it's like 24 or something, I have no idea what the word is. Just say multiplicity of 24. So x equals -2, x equals 1, triple root, octuple root. Let's see. Noah, vertical asymptotes.
Well, you got one, x equals 0.
X equals 0, what kind?
Animal.
Yeah, multiplicity of 10. I think that's a dectuple. I'll have to look that up though. Any others?
X minus, x equals 2.
X equals 2, and that's a
Single.
single. And anything else is gone. Now, are there any wars? Jackal.
Yeah,
Sorry.
vertical asymptote, or I mean, yeah, vertical asymptote and hole.
Yeah, we have a war between a vertical asymptote and a hole. Who wins?
The vertical asymptote.
Yeah, the vertical asymptote wins. Does that make sense? Let's see if we can put this thing together in plus minus notation. Can somebody list me off the breakpoints, the surviving breakpoints, from beginning to end? Pete, help me out here.
So you get a root, a triple root at -2.
True, although there's something before that.
A whole at -5.
Good. At -5, there's a hole. Then at -2, there's a what?
A triple root.
Triple root. Good. Okay.
You get, a vertical asymptote is 0.
Vertical asymptote, 0. Okay. Single, double, triple.
Deck.
Deck. Yeah. Good guys. Deck double. Then keep going.
And you get, root at 1.
Teeny.
That's like octuple
Yeah, there's a root of one, and it's an octuple root. Okay,
And then you get a vertical asymptote in T,
correct. And what kind?
just a single.
Single, good. And this is, well, it's a whole, so we don't care. Everybody good on these? So, region, region, region. There are 5 breakpoints of 6 regions. What would you recommend? Paul? How do we start this thing?
Well, you can't try zero.
Right, unfortunately.
So we can do one negative one.
You can do negative 1, sure. So, for y, use the surviving stuff. I would not use the one up here. So make sure the holes are out of the way. So we've got a 2, which is just positive. And then, yeah, this would be negative to the, well, let me just write this out, it'll probably be easier. And then, that's gone, so then something to the 3rd. I think that's all that's on top.
Yeah.
And then at the bottom, there's a single parentheses, and then a thingy to the 10th. And that's it, I think.
Yeah.
So what goes here?
Is that negative?
Yeah, it's negative 1 minus 1, so it's negative 2 to the 8th power. How about here?
No.
Positive, because negative 1 plus 2 is positive. How about here? Negative. How about here?
Positive. Or,
You're plugging in negative 1,
oh yeah, sorry, it's negative.
so it's negative to the 10th power. How many total negatives in this whole thing?
Three.
There's some more of that.
Oh, negative.
19. There are 19 negatives. What does that mean?
Negative.
It's going to be negative. This region is negative. So, feel this each time, take over. Go to the right. Does the sign switch over a dectuple vertical asymptote?
No.
Which one?
No.
No, why not? It's even, yeah. A double root is kind of like switching the light switch on-off. So the light never goes on. So at any even number, it'll stay. What about here? Over an octuple root. Does it switch or not? No. How about over a single vertical asymptote? Yes. No, take over, go backwards. It's negative here, over a triple root?
So that does switch it.
Yes. And how about over a hole?
It doesn't switch.
It does not switch. Is this hole the result of a root versus a hole?
No.
No, it is not. It's just a plain old hole that x equals negative 5. Yeah. Because they canceled perfectly. There's nothing left. So this is a plain old hole. Doesn't switch. Can somebody solve this for me? What do they want? Jack Lott.
They want the answer in interval notation.
Correct. Which
So,
regions?
Since it's greater than or equal to 0, we want the positive region.
Correct.
So that first one, second one, and the last one.
Right. Do they want the endpoints? Are they asking for the endpoints? There's something in there that'll tell you. Like, I'm wondering if I ever use any square brackets.
Oh, yeah,
Why?
because, the equals.
Yes, equal to.
Yeah.
That means that the expression is asking to use the ends. Now, I don't always give it what it asks for. If it's dangerous, I, like any good parent, would not give it, "Hi, Debbie, can you please give me a scorpion? I want to eat it." No, sorry. "Hey, how about that pit viper?" No. "How about that piece of nuclear waste?" No. Here's a cookie. But there's a story behind that. But anyway, if it's unsafe, don't include it as an endpoint. If it's safe and if they ask for it, give it to them. So the first interval, go ahead, Jack. Very first interval.
X belongs to
Uh-huh.
round parentheses, negative infinity. Or yeah, round bracket.
That's okay. It
Negative
is parentheses,
infinity,
basically.
And
Up to what?
to -5
-5.
with the round bracket,
Why round?
because it's a whole.
Yeah, holes are not safe, bottomless pits are not safe to give to your kid. What's the next interval?
Round bracket -5 to square bracket -2,
Yeah, why square bracket?
because it's a root, it's included.
It's a root, it's included, and it's safe to get. Correct. And,
last
Pete,
one.
finish it off.
Oh,
There should be one more.
So x belongs to two,
Uh-huh.
and then
To infinity. Include two?
no,
No, because it's lethal. And include infinity?
no.
No, you never do, because you can never reach it. This should be your answer. Does that make sense? All right. The next page, it's a huge one. I'll just give you a couple of mental notes on this. You're gonna have a lot of guessing to do, but they did give you one root for free, which means they actually gave you two roots for free. What do I mean?
2 plus negative radical 35.
Yeah, 2 plus negative radical 35 is also a root. Now, what do you do with the roots? How do you get them out of there? And this is one of the rare sections where I would say, do not be ashamed to use a calculator. It's really tedious arithmetic otherwise. But how do you get roots out of there? There are 8 total roots in this thing. That 2 plus radical 35 is taking up room. How do you rip it out? Think daffodils. Daffodils have a bunch of, okay, keep it simple, right? They got a bunch of bulbs and they multiply. How do you get them out? What's the process called? What's the D?
Digging.
Yes, I suppose, I asked for that one. Divide. You divide the roots up. So in other words, if you want to rip a root out of a polynomial, you divide it out. In this case, use synthetic division. I'm going to do one for you just for giggles. By the way, you can go ahead and guess in there. There are 8 roots. Chances are you should be able to guess one. But I'm going to see, just to show you,
Oh, good.
you can actually rip out this disgusting root. It does work. Yeah, he didn't say it's fun, but it's possible. 4, negative 16. Holy mother of pearl. Negative 125. This is getting more and more fun by the moment. 4, 27, 16. 125, negative 4. And then negative 31. Okay. By the way, do you notice there are 9 terms? One thing, you cannot factor by grouping on this. You could theoretically try triplet, 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 but it does not work. Okay. So, hold on your hats. And I don't have a lot of time, so I'm going to go a little faster than normal. I'll do the first step for you. You're welcome. So, multiply, it's going to be 8 plus 4 radical 35. At this point, people usually, their eyes widen and they say, what are you getting into? Add the like terms. Negative 8 plus 4 radical 35. How do we multiply that? Yowza. You boil it. 2 plus radical 35, negative 8 plus 4 radical 35. So this is going to be negative 16 plus 8 radical 35 minus 8 radical 35 plus 4 times 35 itself. You see where I got that last term? Radical 35 times radical 35 is 35 and times 4. This is 140. These cancel. So 130, 124. Negative 1. Multiply that in. So we've got negative 2 plus negative 1 radical 35. You'll need another FOIL. Now the good news is the FOIL, oh sorry, I'll add the like terms first. 2, positive 2 plus, I just do minus. Minus radical 35. FOIL that. By the way, look up here. Ever recognize this? 2 plus radical 35, 2 minus radical 35? That to remind you of a factoring method. Yeah, difference 2 squares. It's going to be square the first minus square the last. This is going to be 4 minus 35. This is going to be negative 31. This is negative 4. Multiply this in. So it's going to be negative 8 plus negative 4 radical 35. These add like terms, so 8 plus negative 4 radical 35. FOIL that. So look up here. We actually already did, sort of. It's the negative version. So I'll just do copy so I can do it. 2 plus radical 35, and then 8 plus negative 4 radical 35. Okay, it'll be 16 plus negative 8 radical 35 plus 8 radical 35 minus 4 times 35, which would be 140. So 16 minus 140 is going to be negative 124. This is going to be 1, and this will be 2 plus radical 35. This will add to be negative 2 plus radical 35. And then if you multiply that together, I'm pretty sure you would get 31. You get 0. Yeah. Now, here comes the fun part. I'm going to let you go in just a second. We also know that 2 minus radical 35 has to be a root. Before you panic, this one's easier. This will be 8 plus negative 4 radical 35. See what happens? 0. Multiply 0, get negative 1, then you get negative 2 plus radical 35. That cancels to 0. Multiply 0, negative 4. This turns into negative 8 plus 4 radical 35. Cancel. 0. You got 0, 1. This will turn into 2 plus negative radical 35. Cancel. Now this was 4x to the 8th. It's now 4x to the 7th. Brought it down to 4x to the 6th. Here's what you're looking at right now. 4x to the 6th plus negative 1x to the 4th plus negative 4x squared plus 1. I propose to you that that will factor by grouping. There's your hint. So, enjoy. Don't forget to bring your books. Please stand up. And if anybody loses any of this in notes, check my YouTube channel. And then scroll to near the end. I don't know what time signature it is, but I'll wait. Let's pray. In the name of the Father, and the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. In the name of the Father, and the Son, and of the Holy Spirit. And how long was this? It was, they didn't tell me. But whatever.